shall hand over to Phil Bangoda, who will be your facilitator for this amazing panel. So please welcome Phil.
Yes, thanks Jenny. My first objective is to break the stereotype that baby boomers can't use technology. So, a couple of things here. Although my passion is sustainability, I did qualify as a process metallurgist and have worked in engineering and technology commercialisation roles over quite a number of years. And one of the privileges of having more than 40 years in the industry is that someone will ask me to moderate a panel at some time more. So here we are. I do want to acknowledge Whittle Consulting, who is my principal client, and they are the ones making it possible for me to be here today. I also acknowledge the Yagara people on whose traditional land I normally live and work, as well as the Kaurna people. It feels good to be here on their country. I'll moderate this relatively conventionally, and which includes cutting short eager panelists or questioners if I need to, just to move us on. So I apologise if you're in the middle of a thought bubble at that point. We plan to approach this in a broad way rather than going deep, so there'll be quite a number of topics, and that's to match the diversity of our panel. There will also be opportunity for you to ask questions. Please use the app to that effect. We already have a few questions already lined up, so to get us started, I would encourage you to go there and to like the questions that are already there, or pose your own, and we'll get to those if we can. Apologies if not all of the questions get aired. And we also have some polls that we're going to ask you to participate in. So at some point, at 2 different points, we'll be posted with 3 different questions for you, and we'd like you to vote, if you like. We're going to be using Mentimeter for that, so you'll need to get your device out and know how to use a QR code, which will be on the screen now and when required. But before we get to the first one of those, I would like to introduce our panel. So here on stage, Angelica Andrade is an international speaker and activist from Brumadinho in Brazil. Angelica's advocacy for safety and justice in the mining sector is driven from personal experience following a dam failure in 2019 where her sister was one of the victims. Currently she is an MPhil student at the University of Queensland, with her research centring on tailings failures and community consultation, pathways to disaster prevention, aligning with her engagement with industries to promote innovative action for all mining stakeholders. Another panellist is Ingrid Oyarzun. Ingrid is a global senior executive leader with an impressive 20-plus year career in the resource sector spanning Australia, America and Europe. In her previous experience at BHP, Ingrid held various strategic and operational roles over the past 19 years, and her collaborative approach has driven effective global strategies leading sustainable innovation in decarbonisation and tailings risk elimination. Now, eagle-eyed amongst you will notice that Ingrid is not actually here. We had planned to have her here, but she went and got a new job, and in fact over the weekend relocated to Paris. So we felt that asking her to get up at 2 in the morning for a 3 o'clock panel, even though she's very passionate, we thought that her first day on the new job should take precedence. So on Friday we asked her to record some perspectives, which you'll see as we go along. Also on stage here is Laurie Riemeyer. Laurie is a principal consultant at this company, Resourceful Parts, and consulting on sustainability since 2016. Laurie is based in Vancouver and has 25 years of experience in base metals and global mining operations, focusing on particularly optimisation of milling circuits and mining efficiencies. He's a champion of using mineralogical data to enhance flotation processes, and also a champion for sustainable mining practices. Also based in Vancouver, but today coming to us from Brisbane, is Nadia Kuntz. Nadia is a chemical engineer and accomplished scholar, and is currently assistant professor and Canada Research Chair at the University of British Columbia. where she leads a research team focused on enhancing water management and governance in the global mining sector. And finally, also in Brisbane is Metplant, who probably doesn't need an introduction. He is currently Chief Scientist at Anglo American and a past Director at the Sustainable Minerals Institute at UQ. He obviously has a global reputation, and his focus currently is on delivering improved operational performance on mining sites by developing and implementing new technologies whilst establishing a global network of research professionals in academic institutions. So that's our panel, and I'm looking forward to the outcomes of this. We're going to start with a Mentimeter. So if you've all got your devices to hand and scan the QR code, and there are some choices there. I wonder if I can give everybody a chance to do that, and then I'll have the questions in front. Thank you. So we've got 5 choices we'd like you to rank. Moment. Item 1 is constraints on operations, so access to water resources, or perhaps treatment of water resources if you have an excess. Social implications and license to operate, considerations such as protesters versus community support, efficiencies in use, technological advancements, systemic leakages, increased recycling, and so on. Perhaps better training or knowledge is something that you're thinking about, and escalating costs. Is the ore body good enough? Do we have deep examination needs, and so on? So please rank them according to your role now. So the questions about in your role currently, how would you rank these challenges? So if you go to the app, you'll find them there. I'll give you a few moments. Excellent, thank you very much. I'll keep going if you want. I think there's some information there. So we're going to use the results from this Mentimeter to inform the road mapping exercise that we're embarking on and the campaign that we're embarking on. So I'm going to get the panellists kicked off now, and the first thing I need to do is to play a clip from Ingrid. So if I can please have clip 1 from Ingrid played. Go.
Primary challenges include water resources scarcity that we are seeing in some parts of the world, and some miners are facing the challenge. Water pollutions that are more related to the quality of the water, and also the increased water demand in the entire industry. These are the 3 main challenges that the mining industry is facing today.
Thank you, Ingrid. I'm going to throw to Nadia first, if I may, in Brisbane, because there's a question that's already been there. Nadia, what are the different types of risks that the mining sector faces in relation to water, and how does this differ across sites? Just bearing in mind what Ingrid said there and your own perceptions.
Yeah, thanks a lot for that, Phil, and great to have the opportunity to be on this panel today alongside such a fantastic group. I think we set the context well there, representing the diverse kinds of risks that the industry can face. And one of the things I always love to tell my students when I'm teaching my mine water management classes, it doesn't matter which mine in the world you visit, there's always a water problem. It just depends what kind of problem that is. So a lot of research has been done highlighting the enormous water scarcity risks that the industry faces, and 2/3 of large copper projects in particular are often in water scarce areas. But certainly when I moved from Australia to Canada, it became very clear to me that water scarcity was not necessarily a pressing issue at a lot of sites, and it was often water quality, it was closure risks, it was flooding risks that were perhaps more important in that context. So I think that's one dimension on risk that I wanted to highlight there, is that it is very, very context dependent what kind of issues the industry will face and what kind of commodities there are can influence that as well. The other final thing I'll say on this also is that risk perception differs depending on who it is we're talking about. So from the mining sector, the types of risks that may impact production may be extremely different from what a community or an investor or a government may think about when they consider risk. And so I'd be very interested as well in Angelica's thoughts on this one as well, because that social piece is so important when we talk about risk perception as well, and can be very different from how the industry may perceive risk.
Yeah, so I'm certainly going to ask Angelica in a moment. Laurie, did you have any addition there? I'm curious on your talking about across sites and the differences between surface and
Yeah, I think probably one of the big things is that with climate change, everything's becoming a bit more variable. So we might have mines that have major water scarcity issues through most of their operations, but occasionally they have massive floods. And I remember some years ago in northwest Queensland, I think every mine in that region had to release water and break their environmental compliance requirements because it was such a large flood. But in general, you have a water scarcity situation. So getting a better idea about predictability in an increasingly variable world is a real risk that we have to challenge, that we have to face, and perhaps how do we design operations that are more robust to be able to handle that variability.
Exactly. So from my perspective, we have a drop in the north in Australia, which has got plenty of rainfall, and they have the opposite problems getting. But then there's transition and so on. So perspective changes depending on where you are. And perhaps Angelica, how do you feel that community engagement is part of this discourse around water access and so on? What's your feeling there?
I think Nadia made a very good point in the sense that there are several risks faced or several consequences that can come to communities by the mining sector, by management or mismanagement of water and tailings as well, which is an issue connected directly to water. And I think that if we want to ensure both sustainability and social equity, we need an interdisciplinary approach. We need technical experts, but we need them to work with social experts to integrate knowledge that comes from communities, and especially indigenous communities, because they have a different perspective, a different way of perceiving nature, of perceiving water and the natural resources. And although I don't share that vision, I really value how indigenous communities perceive water and how they feel a connection to that resource, and I think we as residents need to learn more from them, to respect and have a better relationship to water, which is essential for life. And so I think that engagement is essential to ensure that we meet technical requirements, but also in a way that is sustainable and socially equitable. And so water sometimes, or most of the times, holds significant cultural, spiritual, and economic value for communities. And when we think about the case of Brazil, for example, and the devastation that has been caused there by the mismanagement of tailings, we have to think that these consequences for hundreds of thousands of people will last for perhaps decades. And so we need to make sure that those people receive justice, because that is crucial for the avoidance of future harm. I believe that when companies have wrongdoings, they need to face the consequences of that and make sure that not only local people will have to deal with the consequences. And so, thinking long term, we need to think about what is being done now and how are we approaching water management now.
So I think I'm going to return to the question of risk and because I can see another question a little ahead here. I'm going to get you to hold that thought and come back to the advance notice that we're going to talk about the consequences of not including that. But I do want to just drag in another point here, because we've got diversity here, and therefore I want to perhaps also ask Laurie, perhaps I'm going to just direct this to you. Where do we go with perhaps, well, by the way, Janine, would you like to sit next to, just to make the
Remove that
vision? Yeah,
place. Thank you. It's more intimate,
so the camera can do that. We've got the opportunity to understand the diversity of things, and including diversity across the social spectrum as well as the technical. So, and then there's financial as well. So I know you've got thoughts on modelling, how to improve our modelling. It's not just about hydrology and so on.
Yeah, thanks, Phil. So there's a couple of aspects. I think we've already heard, particularly in grants, talk about techno-economic modelling, which is a component of this. I think when we think about water, we need to understand how the physical system would be modelled at an appropriate level that includes various disciplines, that includes the main directional drivers, that we understand something around how stocks and flows change, how that interacts with technology, how that interacts with cost drivers, but then also things like the metrics of sustainability, things like greenhouse gas emissions, environmental impacts, etc. But also then linking that to the social and environmental ESG related topics in some sort of way. So we certainly need appropriate models. In general, I think we all understand that Excel is not enough in general. You can maybe start with a spreadsheet and get a rough sense of what's going on, but I think one thing that is clear is you eventually need more sophisticated modelling systems. There is a risk though if you go super detailed, especially early, because some of these models might be too complex for people to understand, or they might not be focusing on models that make sense. So I think that's going to be one of the aspects of the project that we'll need to get into.
I'm feeling that there's a holistic nature to the modelling that you're advocating here, and I'm going to bring Nev in here because I know he's got some opinions on this. What are the, because at a small scale it's one thing, but at a large scale it's another perhaps, and I'm wondering, Nev, I know you've got some thoughts here.
Right, thanks Phil, and hi everybody, and thanks for the opportunity to be able to zoom into the meeting from Brisbane. I was hoping to be in Adelaide for the conference, but it didn't work out, so it's just really grateful that I can actually participate. And I think for what I'd like to do is just reflect back on some work that I got involved in about 15 years ago. I'd just been appointed as head of research in Anglo-American Platinum, and my first task was to pull together a task team to have a look at Anglo Platinum's delivery on its water targets. And I went around the company trying to find everybody working on water or had some responsibility for water. And I ended up with about 30 different teams across the whole organisation that all had some responsibility for some aspect around water. And what was interesting is the first meeting where I pulled everybody together, in some cases it was the first time that people had met each other. And it really just speaks to the nature of water and how universal it is across everything that we do within a mining company, but also within our engagement with external parties. So it's an incredibly important commodity that we need to look at, but it doesn't generally end up being owned by an individual, it's owned by multiple individuals across the company. The other thing that then jumped out from that work was, as I got to know what other people were doing within the company, you suddenly started to realise we were all talking very different languages, depending on whether you were a process engineer or a civil engineer, or somebody looking at an environmental aspect in terms of water or in the communities. And in many ways, the models we had developed did not connect, did not talk to each other, and could not be brought together into a coherent picture to give an understanding of what the water risk profile looked like for a large company across multiple sites. And we spent a lot of time trying to build models, and just as Laurie spoke about it, there's multiple different layers of complexity, And as you start to read these different views of water, so that complexity goes up, and the ability to communicate what you're doing becomes more and more difficult. So at the time I was fairly frustrated by this, and I was fortunate to attend a workshop from Chris Moran and Claire Coates was running on the water accounting framework, and they put together an incredible model looking at the hierarchy of these different models and how they're all connected together, and that became the water accounting framework that the ICMM has used, and I found that to be an incredibly useful framework for thinking about complex problems. And I've used it not just with water, but with energy and with multiple other areas. So if you haven't looked at it, it's well worth looking at. It's probably about 15 years old. But coupled to that work was actually work that Nadia did, which I found incredibly valuable at the time, was just tracking conversations on a mine site between people who are working in water. And you suddenly see these massive disconnects between people that really should be connected and dealing with water holistically. So that was about 15 years ago. I think things have moved along a lot, and a lot of the companies now, you will see management at a senior level for water, and to try and pull these different aspects together. But the risk remains that we are disconnected, and the initiatives don't necessarily deliver what we hope, not because of intent, but because of how they connected. Just quickly, from a couple of other examples which I thought were really good was Mitsubishi funded some really good work in Chile, having a look at regional water modelling, and Doug Aitken and his team at SMR's Chile did that work, and I thought that was really good, and they built a tool to communicate that to communities. This is what the network looks like, this is what we can do. So I thought that was really good. And then I suppose the only sort of comment I've got is, from my experience, it's really important to understand the network, the ecosystem, and the multiple stakeholders and how they all connect, because water is such an important commodity and so important to ourselves and society. And then the hierarchical model I found really useful. And then the other one, which I often don't see in water models, is often they like quantity, and often the really important piece that trips you up is the quality of that water and how you're managing that quality. So Phil, I'll leave it there, but if there's any other questions, I'm happy to do.
Well, I'm going to ask a supplementary question of you, Nev, and then I'm going to come to Laurie. I've got this mental model of that disparate people. So it's the disciplines, or sort of a meeting point for disciplines on a mine site. For example, the metallurgist, the tailings dam engineers, and the hydrology or the water husbandry type thing. Three come together. Was that part of the people not talking to each other that you experienced?
I think it was more that they were talking to each other, but they were operating in different scales and different time scales and rates, and their models really used different inputs. So the models didn't necessarily connect, and there wasn't an obvious way to do it. But as I said, this was a good 15 years ago. I'm fairly positive that a lot of that has evolved quite significantly, and I've seen very sophisticated models on sites which connect almost the equipment scale optimizations through into a site-based optimization, which then fits into a regional or local water balance type picture, and pull that together. So the number of frameworks that pull that together, but I think often what's missing is the resolution is very different, and the quality and the uncertainty in the numbers are very different. And it's just being mindful of that and being able to pull that together in a meaningful way. And as I said, I think it has moved along quite a lot, and it's getting a lot better. But it's still something that can trip us up.
So Laurie, do you feel it's got better? That sort of nexus of the three, or is it four? I'm open to understanding better.
I certainly agree with Nev, it's getting better. Also, everything's becoming more complicated. The risks are going up. There's more variability, so it needs to get better just to stay still. One thing I will say is that I think process engineers, process people do sit often in the middle of a whole lot of water issues. I think one thing, this is a process heavy audience, if you like, I think there's really an opportunity for those people to think about how water fits in and interacts at the interfaces of process plants, and how process professionals understanding things like mass balances, both of the quantities of water and solids and slurries, as well as other constituents, how we have some understanding to understand some of those physical aspects of the system. And I think process engineers, metallurgists have been getting better at that as part of the work as the water issues have escalated in terms of risk and cost and concern.
So Ned was talking about a large organisation, so about Anglo American or any of the larger mining companies. How does that translate into maybe a mid-cap or a junior company that's operating? Because the sophistication of things can be different. When you have a lot of resources behind you to what you've done. You've got a feeling on that. You have clients that are smaller as well, right?
Yeah, I have a number of junior clients. I have some mid-tiers. I do a little bit of work for majors, but I think what we're seeing is the likes of some of the majors and ICMM members is they have quite sophisticated teams now that are doing water accounting, water risk management, major projects. Ingrid, for example, was involved quite heavily on the desalination plant for Escondida, which is a gigantic multi-billion-dollar project to basically treat seawater and convey the purified water up to the mine site. So those companies have very large teams, and Newmont and others as well, quite sophisticated reporting now. Some of the mid-tiers have significant resources as well. A lot of the juniors have very few. And I think one thing that comes up in the tailing space often is that the performance of the lagging companies is a reflection on the entire industry. So it's very important that it's not just the major mining companies that are on top of the water issues. We need to get everyone up to that level. And there's certainly gaps, in my opinion, because of lack of resources and perhaps a lack of a long-term time horizon.
Okay, cool. And I'm going to ask Nadia to perhaps comment on that, but also take a question here about risk, because if you're talking about a more junior company or a mid-cap, perhaps the risks are higher or lower, I'm not quite sure, but I know you've been doing quite a bit of work in the area of risks around water. How do you respond to this point, Loris?
Yeah, thanks for that, Phil. And I was going to mention some of that PhD work that Neville mentioned from over 10 years ago now that I did, where I was looking at the disconnect between particularly the mining engineering department and processing team at one case study site where I was doing my work, and ultimately it was the environment team that sat in the middle of that communication. And despite that having been done 10 years ago, I do agree with Neville. I think things have improved, but I still have shown that picture in presentations more recently, and people say, that's my site, they still resonate with that. Whether it's disciplinary silos or whether it's strategy to operations, that's another disconnect that sometimes still exists persistently within companies, and I think that exists in big and small, to be honest. I do agree with Laurie that I think large companies have a lot more resources behind them, and I'm seeing more and more that a lot of major companies have really strong hydrology experts also in the corporate team, which I didn't see a long time ago to the extent that I do now. But I think this need for models that can be targeted to the right level is absolutely crucial. We've been doing some work through one of my PhD students who I supervise with, John Steen. His name is Benjamin Cox, and we've been doing a number of projects with equipment supply companies, including FL Schmidt. We have another project with Erie's that Laurie's involved in as well. And really just trying to build extremely simple models, in fact, that show the economics around making better equipment design choices. And that has resonated very strongly. We've had some really positive feedback on those models. And they're what Benjamin likes to call goalpost models. They're really just designed to be conversation starters to show what's possible. And then from there, you can get the support you need to go into more detailed design options. So I think that, and I've seen this also with hydrology models that may be, extremely detailed, really important for certain decisions in relation to managing water storages on site, but not necessarily resonating with people that may be more senior in the organisation. So being able to develop models that are really fit for purpose, that meet the needs of the decision maker that you're trying to explain risk to, I think is absolutely important. And I do think we need a spectrum of models that serve different purposes and functions, and that should ideally be, connected to one another still. In relation to big and small, I've had some ongoing research collaborations with a company called Erding Resources in Mongolia had several projects with them. And I think they've done some really incredible work, building capacity with local communities around water sourcing and looking at risk from early stage. And I think that small size can also be an advantage for building relationships in the early mine life as well. So I think that there can be challenges of being small, but there can also be advantages in terms of building trust and really coming up with some quite innovative ways of looking at water and managing water, and then making sure that those relations are managed throughout life of mine is the next challenge, especially as organisations grow and change. So I might leave it there, Phil, and let you go on to your next question.
Well, I'm going to segue to Angelica now because I mentioned earlier the nexus between metallurgy, tailings, and hydrology, water husbandry, but I didn't mention the social aspects. So I'm not sure if that's symptomatic of my training and my background, but so Angelica, there's another question here that asks about key indicators for success in social aspects, and I wonder what your perspective is there, but also what are the dangers of us ignoring the social aspects on a day-to-day basis, not just strategically, I think.
Well, if we think about success and if we think about the exact opposite, it would be a disaster. And unfortunately, I come from a story of a disaster. And if we want to achieve the opposite of that, which is success, which is avoiding disaster, about achieving sustainability, achieving community satisfaction, equitable access to our resources, we need transparency, we need accountability. And in my research, I'm going through disaster literature, and I see that the key principle for disaster reduction and avoidance is participation. So back to the first question of engagement, the industry still needs to grasp the importance of participation, of meaningful engagement with communities in order to achieve success. And so we need to monitor also the reduction of conflict over water resources, assess long-term sustainability and resilience of water management practices, and we need to consider that social and environmental conditions change and will continue changing, and we will have more challenges with climate change. And so, as I said before, I believe success will only be possible depending on what we do now, what changes are implemented now. I don't think business can continue just as usual, and we need to see what kind of legacy we want to leave, and for that we need to manage the resources today.
Thank you. I do want to come back to climate change as well. I think could we please have Ingrid, and just to mess with people who like things sequential, I'm going to go to Ingrid's clip number 5, if we can, please.
I think that it reinforces how important is to understand the critical that collaboration is to solve the common issues that we have in the mining sector. Understanding the risk that we can bring when we start working in any new technologies, and how we can address properly this risk, but also how we can work together to make it economically feasible. That can be really an opportunity and not an earning problem for the mining. I think that risk, social value, and economics are three fundamental key value drivers that we need to put focus on in order to achieve the goal.
So, thank you again, Ingrid. So Ingrid's talking about a couple of things there, but one of them is again collaboration. So the words collaboration and communication come up all the time. Neville, can I bring you back in here? Ingrid's mentioned that importance of collaboration, but I've got a question which is dear to my heart because I've been in commercialisation of technology in parts of my career, and we were always rabidly protective of our intellectual property, and I suspect that there are many companies that have policies around protection of their intellectual property. Are you seeing any change in that? I mean, is this ultimately a barrier to collaboration, do you think?
So Phil, I think that's an incredibly nuanced question, and I suppose the easy way out is to say it depends. So maybe if I can make a couple of statements that I think are good guiding principles. I mean, I think the first one is it is important that companies are able to protect their IP, and they're also able to generate benefit from their investments in IP, and they're able to differentiate the organisation. If we don't have that protection and that the ability to benefit from your investments, what we'll see is the funding disappear for creating new technologies. So there's an aspect around that where it is important, and it's great to see IP protected, and it's great to see IP commercialised. And by experience, having worked across multiple sectors now, and stepping back into a large organisation for the last year, was in many ways the large mining companies and the management policies and IP policies that I've been involved with have really been there to achieve a couple of things, and one is to ensure that the company maintains the freedom to operate. So if something's developed, the company wants to be able to use it. And the second one is that the company doesn't infringe on anybody else's IP. And a lot of the policies and procedures are there really to manage those risks. However, often that comes across as locking up IP because you're trying to manage a risk where you feel you may not be able to use the IP you've developed. Now, that's all manageable, and there are ways around it, and a good negotiation and good commercial terms can deal with those risks fairly easily. If you step into a small MEX company, which I have had the privilege of sort of running one for a while, is your IP is absolutely critical, and the patents that you hold, they differentiate and they articulate your ability and your position in the marketplace. So there you have to be very defensive, and you have to be able to say, right, this is what we've got in terms of our IP. So you put that all into a mix, and then you try and accelerate technology development, get technology onto site, and it becomes really, really difficult. And I sort of shudder to think about the amount of hours I've spent negotiating IP clauses, probably more than actually getting the work done and getting the technology into site. But it's largely set up to manage those risks. So I suppose where I'd like to leave it is I think there's an opportunity to sort of really have a look at the space, and for companies across the spectrum to be very deliberate in their technology strategies and in their IP management, and be very clear that this is what we need to protect, and in this area we can collaborate as a sector. And I think it's really trying to bring organisations together to collaborate on specific topics that are really, really important to the sector, and the sector needs to solve. And water's definitely one of them. Social performance would be another. A number of the climate change, biodiversity challenges. These are sector-wide challenges. And in those areas, we've got vehicles for doing pre-competitive research, for being able to manage the IP and being able to say, look, we actually are not going to protect this. This will be an open innovation space. Being able to share that. We've got organisations that build these collaborations. But I think what's critical is that the sector is clear. We're going to collaborate in the space, and therefore we're going to manage IP in the space differently. And I think it's very doable. So it doesn't need to be a barrier. I think if you would like it to be a barrier, it's a very fantastic, fertile area to put blockages in the way. But I just think the sector's got to move beyond that if we're going to answer a lot of the challenges, particularly in the sustainability and social performance space.
Yeah, right, so Laurie, given what Liv's just said, and water being, if you like, so ubiquitous and universal to all aspects of human life, we're probably all very happy with IP being locked up on a fantastic new metallurgical recovery system or something like that, but what about water? Is it a different class of beast? We ought to make it a bit more the commons, or what's your feeling there?
Others will have comments on this, I'm sure, as well, but I think there is some tension there, because I think because of water's connection to humanity, to the well-being of people and the environment, I don't think you can treat it as a competitive advantage to making more money. I think there were situations with Bechtel, for example, in Latin America, where they were trying to stop people from collecting rainwater, for example. because Bechtel had invested in infrastructure for water delivery, and it just didn't work. I think one example of collaboration that I think worked very well in Latin America was the Cerro Verde mine, where basically that mine needed to expand. It needed secure water supply for a major capital investment. There were all sorts of issues in that region with water pollution from farming in the river system and so forth, and the company was able to collaborate with a range of stakeholders to come up with a solution that they would invest in water treatment, they would provide a certain amount of water into communities and upgrade infrastructure, the mine would get its water. A number of people are involved in coming up with that type of solution, and it really solved a range of issues. And I think they're the sort of models that I think are important. When it comes to technology solutions, I think there is some tension there as well, of course. We talked about coarse particle flotation earlier, a number of technology providers of that. I think what I'd like to see is that there is healthy competition that allows the industry to select a number of these technologies that move us in a direction of, for example, pre-concentration, creating coarser waste materials that can be easily dewatered and drained, for example. All those things move us in a good direction. So as long as the providers of technology and so forth are not, as Nicola said, trying to create barriers for the whole industry to move, I think it can work.
Yeah, I feel there's a different attitude when you get to different aspects of what we do in the mining industry on the concept of IP. I've got a question here from Dean David, thank you, Dean, which points to a sort of associated, but flipping it to tropical locations and water excess now. So access to water is one thing in water scarce areas, and competition with agricultural or environmental or indeed cultural aspects. But what about, Dean's question is, environmental plans are increasingly zero release, even in tropical locations, and we're increasing risks by not allowing for planned releases in exceptional circumstances. So that's sort of managing the storage of water, I guess, for it can be released or treated and released. What's your feeling there? I do want to address water excess rather than Australians typically think water is a shortage, but we do have a tropical north, and Canada has a non-tropical north as well.
Yeah, so I'll make a couple of comments. I think, firstly, segregation of clean waters from the waters that interact with mine waste is incredibly important in those environments. And I think many people in the audience will understand that. It's just now that as climate is becoming more variable and as the facilities are getting larger, it becomes more and more important. And the footprint of wastes, because it's getting larger in general, also increases the volume of waters that might interact with those wastes. So that's the first thing. And I think when you think about, for example, a mining system, you think about something like a block cave mine as opposed to a large open pit. There's an example where you can fundamentally change the footprint, certainly of your waste rock dumps, in ways that reduces the amount of potentially problematic materials that might interact with water that would create situations that are more difficult that Dean is describing, for example. So I think there's some of those aspects that can be considered. Look, in general terms, I think there are mines like in Ireland. I visited a mine in Ireland in 2000 that was regularly discharging water because it's very wet. They happen to have favourable geochemistry, the carbonate ore, so that wasn't too bad, but it still creates perception concerns, right? Like if a community has a mine that is releasing water, there's always some fear that that water quality is not good. And if there's a turbidity problem, well, it's visual. If it's not a turbidity problem, well, then it's harder to see if the water is good or not. And I think in those situations, having appropriate monitoring that includes members of the community in terms of, for example, the collection of samples, independent verification of data, real-time data, I think that's very important. There was a presentation that was given by the head of the borax operations a few years ago at the SME, where he talked about a movement towards more transparent and real-time monitoring that included members of the community. And I think that's a really powerful way that you can build trust about our water systems and about the qualities of waters that are being released. into the environment or for human consumption.
So I guess Dean's question was not just the systematic releases of water, which are under controlled conditions and water treatment and so on. He was also talking about high rainfall events and climate change in his question as well. Does that change? Should that change the rules? I guess I'm nervous about changing the rules for extreme weather events, but it's something we have to face, right?
Yeah, look, I think the main thing with extreme weather events is you've got to be looking at catastrophic impacts. So tailings facilities, for example, are very subject to catastrophic failures if there are floods in excess of design parameters. If you have overtopping or something like that of a dam, you're going to get a catastrophic failure. So that's obviously very important for the industry to recognise. In general, as we get bigger, the consequences of failures go up. I think that's a key thing. And so we really, I think, need to be thinking as an industry about can we manage that tension, or do we have to think about other ways of building facilities, other ways of mining, etc. And how does that change over time? And obviously, we're on a path at the moment of continuing to increase in scale, but can we really continue to do that forever? Or do we need to be starting to design the technologies that allow us to mine and process in different ways that have lower risk?
These are great questions and perspectives. Nadia, can I bring you in to comment on this one as well? I feel your Canadian experience.
I'd love to jump on this one, Phil. Thank you, because I think this question of managing in extreme environments and particularly under kind of crisis scenarios is one that is a very topical one. And Laurie mentioned the very close relationship between water and tailings, and certainly there are many triggers for tailings dam collapses, but excess water on top of the dam is one of them that has been associated with a lot of devastating tailings failures. I believe some of the Brazil cases had that as one part of the puzzle, but likewise in the Mount Holly example in Canada, excess water on top of the dam was also part of the reason that dam collapsed. So I think that this question of being able to release before a major consequence happens is definitely something that is important to think about, and that should be a part of the solution for particularly dealing with more extreme weather in future. Having said that, I think a lot can also be done to better plan in advance for high rainfall events that might be coming, and I think there have also been examples, and certainly some of the diagnostics that have been done on tailings dams, they never point to one source of failure. There's multiple points where things fell down. And so I think in the case of water excess, I remember, again, going back to my PhD work, talking with dewatering technicians on the mine site where I was working, and this dewatering technician was so frustrated because, they said in the dry season, nobody gives two hoots about pumping. Nobody wants to invest in infrastructure. The pumps aren't working properly. Then the wet season hits and everybody says, panic, quick, get the pumps working again. So I think that this water is unfortunately something which, until it's critical, it's kind of not getting the right attention sometimes to invest in our infrastructure to make sure we're planning well for what might be an upcoming wet season. And I think regulation is getting better on that. I have seen some changes in more recent years. But one of the challenges as well around designing for climate variability is we often don't have good data. So you're trying to make predictions about future variability, and the design parameters are going to be limited by what kind of historical data exists for a site, and also how accurate those climate predictions can be. So there's some very real challenges there around, even if you've got the best design possible, there can still be these envelopes where things can go outside those boundaries. So I think it's a really important question that was raised there, and one that is absolutely crucial. But multiple solutions are important to deal with it, and I don't think it's just about regulatory allowances. I think there's also a need for a lot more strategic forward planning in relation to water management earlier.
Thank you for that perspective. Janine, I think you want to ask a question, so while you're walking to one of the microphones, I don't know where you are. I'll just point out I did a bit of work myself at Ranger, and during my time working on that closure project, they had a excess excess rainfall, and they were forced to store water in the production pit, which put them out for several months. I'm thinking 6 months, if I remember correctly. So this was a sort of an answer to Dean's question about should they have been allowed to release? Well, we were talking about uranium, which might be a little different to some other commodities, but that's just a question about changing the rules or not on these things. Janine?
Yeah, thanks, Phil. I wanted to bring us back a little bit to the question of IP, and perhaps if you and some of the panellists could talk a little bit about SEEK's approach to this global water initiative and how we plan to handle those matters, and that our philosophy is essentially water is different from other things, and we simply have to collaborate, and we have to have a certain amount of leaving IP at the door in order to raise the standards for the industry overall.
Yeah, certainly I can speak to that if you like. It's what you're saying is that SEEK has always been about sharing and being a place to go for the leading edge or the leading thinking on these things. And the collaborations and the research we have in mind is certainly the intellectual property that will be developed will be free to use for everybody or free to access for everybody. So that's just need to bear in mind. I see Grant, you're hovering in the microphone probably because I've been ignoring your question in the app. Is that right?
Yes.
Go for it.
So, Valentine Zenka, I was just wondering if the panel can comment on what strategies and technologies are available to significantly reduce water consumption on site or in mineral processing conference, so that would be useful for the audience to know what strategies and technologies are available to significantly reduce water consumption.
So, Laurie, I know you've got, I'm coming back to you all the time, but I know you've got a thought around using different, perhaps we'll answer that by leading into a question that's already in there as well, which is about using lower quality waters, and perhaps that's a way to...
Yeah, I think we might tie this together. So I think one key aspect is it's high quality water sources that are under most stress. So if a mine site, for example, like Cadia some years ago, during the middle of the Australian drought, was having some tension with its local community, the town of Orange, and trying to convince the community that the mine should get the high quality water and that everyone else would run out, if you like, in a sense. That was certainly a perception. And that obviously doesn't stand. I think what's happened with Cadia, for example, is that they've gone to lower quality water sources, taking sewage treatment waters and so forth, and in conjunction with changing the process for better dewatering of tailings. So clearly, I mean, and Grant, you've talked to this a bit, creating waste products that are easy to dewater is certainly part of it. The dewatering using either high density thickening or filtration, etc. But even changing the practices of tailings management to get better reclaim. I think the Chileans have had some very good success in terms of how they design tailings deposition and water reclaim. But that only gets you so far, especially as head grades are falling and tonnages are going up. So I think pre-concentration remains a technique that can be used to reduce the quantity of material that has to be turned into slurry, if you like. But ultimately, if you look at the water intensity, things like heap leaching are far lower intensity of water use on a per tonne basis. And as ore grades decline and tonnages have to go up, I mean, lowering intensity, whether it be energy intensity or water intensity, are fundamental strategies that need to happen in order to hold at bay all the environmental impacts and its associated social impacts that come from these very, very large mines. So I certainly, there are likes of Jetty Resources, for example, that's doing work in different types of heap leaching, catalysts for doing heap leaching of low-grade chalcopyrite ores. That's been something we talked about that I studied at UQ about 30 years ago, and that was talked about then, and it's a very difficult thing to try and crack. They're testing it. We hope they'll have success. And eventually, other techniques, in situ leaching and so forth, those things will require investment by the industry, and I think a collaborative effort to see if we can make those things work.
So I want to ask Neville if he's got a perspective on this as well, and I'm going to wrap in another question from the audience, which is from Mohammed, which is how to entice investment to keep new and better technologies, so water reduction technologies or water treatment technologies, and conservation, which is potentially also what you're talking about. So Neville, have you got a response to the, I guess Grant was asking about water reductions, and Laurie was talking about water intensities, like you talk about carbon intensities and so on. And Mohamed's asking about investment in that. So is that too nuanced this time, or are you okay?
So I think we probably could have a 4 or 5 hour workshop on that topic. So I suppose I was busy writing furiously because I was panicking that you were going to ask me the question. And I think I've pretty much aligned very much with Laurie. I think the first step is you've got to mine less waste. So there's no benefit in mining waste. We can mine a huge amount. We've got to get efficiencies there. And then the other one for me is that often the issue with water is a quality perspective, which Laurie mentioned as well, and how can you recycle water as quickly as possible and therefore not lose the water that you've got. So just really manage that water much, much better and be very focused around water quality and what is the appropriate water quality you need for a process. And I'm amazed that often when mine sites are water constrained, suddenly the process can handle lower quality water. But if you've got water inside, just conserve every drop. Now the tailings piece, I think that's well documented. I mean, if you can really separate out a very, very coarse fraction that you don't put through the process plant, and you can deposit that on the tailings, you can get better drainage. It all works. And that's definitely the breakthrough that's coming through now. And I think there's huge value because you get two things out of it. First of all, you don't have to use up all the energy processing that waste, and second of all, that waste drains so much quicker, so therefore you get the water back quicker, and therefore you also get a bit of quality water coming back. So there's just huge benefits in that space. So that reconcentration, less waste. And I think, and thinking, being very, very mindful around quality. And there was a huge amount of work that was done by Kerry Slatter, and that's also work that's been done at UCT in terms of platinum operations, looking at the impact of water quality on processes. And I haven't seen that replicated often. George Levi did a lot of work at the Ian Moore Institute, did a lot of work on this, and it's just been very, very clear on what is the minimum water quality you can use. And treated sewage effluent is a number of plants around the world done on that, and therefore you're not competing with society for potable water, which is where the big constraint is. In terms of all the dry processing technologies, a lot of work has been done in that space, and it's something probably I would have on my next 10 to 20 time frame. The big challenge is dealing with the health issues of dust and how do you manage dust. The actual dry separation technologies, I think, are well defined and are available. So just mindless waste. In situ work, fantastic. Heat leaching, fantastic. If you have to put it through a process plant, there are options around dry processing.
Can I talk on this one as well, Phil?
Yeah. So Nadia, yes, you can. But Tim, maybe Mum wants to make a comment. So another thing to the right of the SMI. So that's okay. While Tim is moving to the microphone, have your say.
Okay, great. I just wanted to quickly jump in on the opportunity for mineral processing engineers because I appreciate Grant's point about the nature of the conference and everything, and I echo the responses that Laurie and Neville have given already around what those opportunities are in terms of water reduction. I think thinking about kind of the front-end technologies, thinking about what you're putting through the process in the first place to reduce your actual water use per tonne of product is really important, as well as technologies at the back end in terms of reducing the amount of water that ends up in tailings. We know that that's one of the largest losses of water at many sites, tailings losses, so anything you can do to reduce water use there or water loss there is very important. But I just wanted to make two really important points here about trends of where the industry is going and the opportunities that creates for mineral processing, because one of them is we know that we're mining lower and lower ore grades. Unless we do things dramatically differently, that is going to result in more water use per tonne of product. So I think thinking carefully and strategically about, as Neville said, like what can be done before things get to the processing circuit so that we're not putting waste through the circuit as much as possible is crucial. But also, one of my students, Sally Enos, did a tremendous estimate for the World Mining Congress earlier in the year, looking at tailings generation volumes for Chile alone. She found over 1.5 billion tonnes of tailings by 2040 is what the estimate is. Basically, exponential increase in tailings production, and that's a lot of we see those trends in lots of places in terms of if we do things the same way forever, this is what's going to happen. And so I think the opportunities that exist in terms, and Laurie mentioned this as well, how can we deposit tailings differently? How can we really think about the kind of legacy we're leaving? Because it's not just about managing water use and water management during life of mine, but also at closure. What is that legacy we're leaving, and how can we make sure that water quality and closure issues are not going to be a huge liability for the industry into the future and for communities?
Thank you, Nadia. Tim.
Thanks, Phil. Tim Neville, I'm JK Centre. I just want to pick up on some things Neville said about dry processing. The best way to solve water problems is to get rid of water. And that's the obvious statement. Dry processing has been looked at quite a bit. We looked at it some years ago in great detail. And for pretty much every wet process, there is an analogue dry process. So there are dry comminution methods, there are dry classification methods, there are dry density separation methods. High tension separation, which is currently used, as we all know, in mineral sand dry plants, has many years ago been used in applications for which flotation is used now. So all this stuff is around. The big problem is water is a fantastic material. It's a reactant, it's a conveyance system, it's high density, high viscosity, so it supports particles. That's why we use water. So every time dry processing comes up, we all say, yes, let's go dry processing. And as you start to probe and look at how we would actually do it, it turns out to be energetically impossible. Most dry processes are hugely energy consumptive, and we know exactly that's a bad idea today. However, I think it is an idea that has merit, and I think it would be nice to spend some of our intellectual resources spending a bit of time, and I make the offer to the people in this room and on the panel that we should start taking dry processing a bit more seriously and do a more thorough study of where it might fit. Because if it's dry, you don't need the water.
Thanks, Tim. And David gave a very good talk around vertical roller mills a few weeks ago at one of the JK lectures on Fridays. If you haven't seen that, it's on YouTube, so I've watched it, it's very good. He's going to be getting some questions from me later on in the week, so you can buttonhole Dean, I'm sure, about vertical roller mills and their applications. So it's a dry comminution process. You're still going to flotation after that, but at least it's a step on the way. And those are the sorts of things that I take Tim's point completely about the high energy use if you're doing everything dry, but at least take some part of it out if we can. So, Laurie, you got anything you want to add there before I move on to the next topic? Well, you could go on forever.
I take Neville's earlier point. This is subject of probably what's going to come up in the subsequent workshops.
I suspect so. And I mean, we've spoken about social and other things here, but the technology angles are numerous. Could we please play Ingrid's clip 3, please?
Adaptation involves assessing different climate change scenarios, taking into consideration local and geographical conditions, also enhancing water efficiency in the current process, which also involve how we can use different type of process which requires use of water in order to maximize the use of water. And the third one is water recycling system for processed water. And in this particular case, we have one clear example that is related to tailings. In the case of tailings storage facility, we lose a lot of water for evaporation. But also, if we could manage or if we could capture the water from tailings, we can reduce significantly the risk in the tailings storage facilities. And we can enhance social value and community perception. However, the main challenge is how we can make it economically viable and feasible. This is the main opportunity that we have. And in today's world, limited access to water sources, coupled with the rising demand of water, has made effective water management more challenging than ever. Innovation solutions, sustainable practice, lesson learned, best practice, and working collaboratively with the entire mining ecosystem is critical to address properly the goal.
Thank you, Ingrid. So, Laurie, Ingrid's talking about a number of things there, including climate change and the water contained within our tailings dams. So it's not just about the evaporative losses, but it's also about the interstitial parts of the solids where we look up. And so, of course, the grinding helps in those areas. But I like the thought of addressing the waterlogged tailings. Where do you feel we are going there?
The key thing is, can we produce less tailings? Certainly less tailings that need to be stored in a slurry form. I think that's really key. And thinking about landforms, and I think, and I'm sure Angelica might have some comments on this as well, when we deal with Indigenous communities and so forth, they're often thinking about what landforms want to be left behind. And so when we deposit tailings, it's not just about doing it at the lowest cost during the operating life of an operation. It's really thinking about how that fits into the long-term landform that you're trying to create, and the amount of water trapped in the tailings is going to affect that in a significant way.
Right. Angelica, please have a response to there about reduction in tailings and where does that sit with communities? Clearly, there's a lot of risk, but what else do you feel?
I think when we think about tailings, and even I have this tendency to think about the sudden, acute, catastrophic events such as what has happened in Brazil, but we also need to consider the slow and gradual disasters that form, and not only in more vulnerable countries such as mine, but if we think about Australia and Kenya, that's one example of an issue with the community that has happened in a developed country. And I think nowadays most people don't consider that much what happens when there is a problem with a community, because the consequences are being felt mostly locally for people who are around mines. But I think what society is failing to perceive is that as time progresses, we all might face a consequence in the sense that we all need fruits, vegetables, meat. Where does that come from? It comes from a rural community, and that's where mining is. And so what we saw in Kenya should serve as an alert to all of us that if water is not managed properly within a mine, that affects agriculture, that affects cattle, that could possibly affect your kids who buy fruits and vegetables and meat from a supermarket. And so it is something that concerns all of us as humanity, not only indigenous peoples, not only people living close to mines, but we need to think about what's going to happen in 20 years. Even though we might live in a big city, we need products that are locally produced somewhere. What kind of water are they using? What kind of soil is that being produced? Has it been contaminated by dust, by tailings, or some other form of contamination? So I think we all need to think about that, not just marginalized and vulnerable groups, but we all might at some point become vulnerable as well.
So thank you, and I'm going to go back to the Mentimeters shortly to sort of round out our panel discussion. I'm able to come back to you for one more question in a moment. But I think what Angelica said there segues me to a point that I'm keen on, which is you'll have noticed that we don't have Indigenous Australian on the panel, and I hold the view that non-Indigenous people shouldn't be speaking for them, and so we went, and though we couldn't secure an Indigenous speaker to be on the panel here, I did manage to get a quote from somebody important, and I'll read the quote. It's, "We are all natives of this earth, and water is the mother's milk, and it belongs to all of us." So just think about that. That quote's from a fellow called Roy Jansen, who's a Marangunuru man and former elder of his people from the Finniss River region, and whose traditional lands are impacted by the jungle mine. So I know that Roy and his clan, his family, doesn't have access to all of the traditional lands because of that mine. And I also know that Roy and his family and clan have a 1,000-year plan for that area. Now, a 1,000-year plan doesn't normally enter into the discourse of a mining company's investment in a mine. And I'm sure somebody here would be able to quickly calculate the NPV effect of $1 million at year 99 or at year 999. It's pretty small. So I'm keen on including research into Indigenous ways to teach us things, not just communication and understanding their cultural aspects, but ways to include their skill sets and their learnings and so on. So Nadia, I wanted to throw to you at that point because you've had some connections with North American Indigenous or First Nations peoples. Can you tell us a little bit about that, just to finish off the panel discussion?
Yeah, I'll maybe just touch on two small reflections that I have, and I completely agree with you, Phil. I certainly don't want to speak on behalf of any Indigenous peoples, but I did just want to highlight two things that I've heard and experienced in some of my conversations in Canada. One actually links to the conversation or the last set of questions we were addressing around closure and around legacy issues, and they're actually, I have heard some communities in Canada speak about not wanting any perpetual water treatment as part of mine design. We have a lot of perpetual water treatment as part of mine design in Canada, and I think it's, from my perspective, fantastic to challenge us to think, what does design look like without perpetual water treatment? And I have seen that being pushed for in some places. I was also on a panel at the CIM conference earlier in the year with Christy Smith-Haddock and Lana Eagle, who are two wonderful Indigenous women who I've learned much from. But Christy was reflecting on some of the work she'd been doing, and this relates to how we communicate technical information. I remember her talking about to some of the communities she'd worked directly with that water couldn't be separated into surface and groundwater. So water is water, and kind of using, to me, groundwater and surface water is not a technically complex differentiation, but certainly, just thinking about how we communicate, referring to water as being in different categories may not be helpful depending on who it is you're engaging with. So I think just being very respectful and cognizant of listening and learning, and I think Angelica also spoke very much about what we can learn from Indigenous communities, and I completely support and agree with that. I think there's much to be learned, and I'm still on a journey of learning myself, but I think I've gained a lot more from those engagements I've had in the Canadian environment. There have been a lot of wonderful work going on there, and as I know that there is also here in Australia around leading by example from our Indigenous partners.
Thank you, Nadia. So I'm going to now pull us into a little bit more data gathering here and audience participation. If you could get ready for another Menti. So this is going to be the same category, so I won't re-explain them. But this time I'd like you to think about the industry as a whole, not just your own job. You may have the same ranking for the industry as a whole as your own job, but please have a think about it in those terms, and please vote again or order them again. And then I'm going to come to a third one straight after this. If anyone needs to hit the QR code again, it's on the screen. give a little moment. Can you reach 100 responses? Very good. I really appreciate it. Surely, fantastic. Maybe we can bring up number 3 now. So this is slightly more complicated. There's 7 or 8 options, I think, here. So it's a little bit like a federal election preferences here. And these are lines of research that you think should be done or are being done or should have preferences here. Please rank these in order of your preference. Give you a little bit longer for this one. Once I asked ChatGPT, that device came up with something I didn't like, but a friend of mine offered a very good one, I thought, and that is a void of mining engineers. And so if anybody's got a better one, I'm looking for one, so you come and see me at the booth later on. And if you've got one for a collection of process engineers, I'm probably not that much interested. So anyway. I will draw this to a close, and the first thing I want to do is to thank our panellists, both in Brisbane and here, and of course Ingrid in Paris. So if you would please join me in